Right now, as you are watching this, the maps meteorologists use to track extreme heat are showing something that does not normally show up on them at all. On the 7th of August, New York City recorded a dew point of 79 degrees Fahrenheit, just 1 degree short of the all-time record for the city, a humidity reading more typical of a rainforest than the northeastern United States. At the exact same time in Lake Charles, Louisiana, the heat index climbed to 121 degrees Fahrenheit while the region sat under both a tropical storm warning and an extreme heat warning GE simultaneously, the first time those two warnings have ever overlapped there since 2005. And far to the north, in a state where dangerous heat is almost never part of the conversation, heat advisories have now reached interior Alaska, a place where summer highs approaching 80 degrees are considered a rare, once every few years event. This is not the same heat wave that opened this summer. Something has genuinely shifted in how this heat is behaving, and the shift is showing up clearly in the data, not just in how the air feels on any given afternoon. This is the story of how a dry, classic heat dome pattern turned into something far more humid, far more dangerous, and far more geographically unusual than anyone forecasting this summer expected back in June. No hype, no exaggeration, just what the maps and the meteorologists tracking them are actually saying. Drop a comment and tell me if the air where you are has felt noticeably muggier the past few days, because that feeling is not in your head. It shows up directly in the data we are about to walk through. If you want grounded weather breakdowns instead of vague headlines, subscribe. It is free, and a like helps this reach people who need to see this before their own forecast shifts the same way. Let us go for 5,000 likes on this one. Thank you. Now let us get into it. To understand why this shift matters so much, you need to understand the difference between the kind of heat this summer started with and the kind of heat it has now turned into. Earlier heat waves this year, the ones that baked the central and eastern United States around the 4th of July and pushed Billings, Montana to an all-time record high of 111 degrees Fahrenheit on the 12th of July, were driven primarily by dry heat domes, ridges of high pressure that trap hot air in clear skies, but do not necessarily come loaded with tropical moisture. Dry heat is dangerous, but the body has at least one functioning defense against it: sweat, which evaporates efficiently off the skin in low humidity and carries heat away with it. What changed over the past several days is that this heat has started merging directly with tropical moisture, most visibly when Tropical Storm Bertha pushed into the Gulf Coast and placed southern Louisiana under a tropical storm warning and an extreme heat warning at the same moment, something the region had not experienced together since 2005. When humidity climbs that high alongside extreme heat, sweat stops evaporating efficiently, the body loses its primary cooling mechanism almost entirely, which is exactly why meteorologists track heat index rather than raw temperature during events like this one, and why a heat index of 121 degrees in Lake Charles represents a genuinely different, more dangerous category of event than a dry 115-degree day in the desert Southwest. The New York City dew point reading tells a related but slightly different part of this same story. Dew point measures how much moisture is actually present in the air, regardless of the air temperature itself, and a reading of 79 degrees is exceptionally rare for the northeastern United States under any conditions, let alone in a city not typically associated with tropical humidity. Samantha Burgess, Global Strategic Lead at the Copernicus Climate Service, has pointed out this summer that heat waves across multiple continents have been especially noticeable at night, making it difficult for people to sleep, which in turn impairs both health and the ability to function the next day. Extreme humidity is a major reason why. Overnight low temperatures are supposed to give the body a chance to recover from a hot day, but when the air stays saturated with moisture after dark, that overnight cool down weakens or disappears entirely, stacking one poor night of heat exposure directly on top of the next, with no real recovery window in between. The reach of this pattern into Alaska is, in some ways, the most striking sign that this summer has moved into genuinely unusual territory. Heat advisories issued for interior and south central Alaska this month mark only the second year the National Weather Service's Fairbanks and Juneau offices have even had a formal heat advisory system in place. A system that only began operating in 2025, specifically because these kinds of events have become frequent enough to warrant one. Temperatures approaching 80 degrees in parts of south-central Alaska occur so infrequently that residents there describe them as a once every few years occurrence, and the same high-pressure system responsible for that Alaskan warmth has been described by meteorologists on the ground as an unusually strong, persistent bubble of warm air settling in and shielding the region from the cooler weather systems that would normally break a pattern like this apart. Copernicus Climate, scientists tracking this entire summer describe the pattern bluntly. These heat waves are not isolated events happening independently in different countries. They are part of the same broader signal showing up simultaneously in Europe, North America, and South America, evidence of a warming pattern operating at a scale far larger than any single region's weather. It helps to understand the broader atmospheric setup sitting underneath all of this, because the shift toward humidity did not happen randomly. It happened because of where the pressure systems driving this summer's heat have positioned themselves. Much of this summer's extreme weather has been driven by a recurring pattern meteorologists call an omega block, a ridge, of high pressure that settles in place and effectively refuses to move, flanked by low pressure systems on either side, resembling the shape of the Greek letter the pattern is named after. Persistent omega blocks have already been tied to the Marchu. Heatwave in the southwestern United States, the Independence Day heatwave in the northeast, and the string of heat waves that hit Europe in June and July. A stationary block like this does not just trap heat. It also blocks the atmosphere's normal ability to flush out moisture, and when a ridge positioned like the one currently sitting over the country happens to draw in Gulf moisture or interact it with a tropical system like Bertha, the result is exactly this kind of merger between extreme heat and extreme humidity, rather than the drier heat domes that dominated earlier in the summer. Our researchers studying this exact mechanism point to Arctic amplification, the fact that the Arctic is warming 2 to 4 times faster than the rest of the planet, as the underlying reason blocking patterns like this have become more frequent and more persistent in recent decades, since that faster Arctic warming shrinks the temperature difference that normally keeps the jet stream moving in a relatively straight line, rather than buckling into these stationary formations. It is also worth being clear about how this year fits into the broader pattern of extreme heat globally, since context helps separate genuine escalation from ordinary summer variability. Climate scientists monitoring conditions across multiple continents this year have noted that, taken purely by the numbers, this summer has not technically broken as many all-time heat records as some recent years, but they specifically flag that the reason may simply be that an even stronger El Niño signal has not fully arrived yet, with some forecasts suggesting the more extreme records could still be ahead later this year as that signal strengthens further. In other words, the shift toward more humid, more dangerous heat happening right now across the Gulf Coast, the Northeast, and even Alaska may be occurring before the season's most intense phase has even fully arrived, which is precisely why meteorologists are treating this week's data as a signal worth taking seriously, rather than dismissing as a temporary blip. There is a genuinely useful comparison sitting inside how differently prepared regions are, handling this same shift toward more humid, more dangerous heat. Communities along the Gulf Coast, despite facing the most extreme heat index readings, generally have decades of institutional experience with both hurricanes and extreme humidity, widespread air conditioning penetration, and public warning systems built specifically around heat index rather than raw temperature. Interior Alaska has almost none of that infrastructure, since air conditioning has historically been considered unnecessary in a state built around surviving cold rather than heat, leaving residents there with genuinely limited options for cooling down during exactly the kind of prolonged warm stretch now settling over the region. That gap, extensive heat infrastructure in the place facing the most extreme numbers versus almost none in the place experiencing the most unprecedented numbers relative to its own history, is precisely the kind of mismatch that tends to produce outsized harm even when the raw temperature reading looks less dramatic on paper. So what does all of this actually mean for you, wherever you happen to be watching this from? If you live anywhere along the Gulf Coast or the northeastern United States right now, the practical takeaway is to start paying attention to heat index and dew point readings specifically, not just the plain temperature forecast, since this shift in the underlying pattern means the plain temperature number is currently understating the real danger in a lot of these locations. If you live somewhere that has not historically needed to think about heat risk at all, including places like interior Alaska, the lesson from this exact stretch of days is that an unusually warm pattern can still be genuinely dangerous. Specifically because a lack of air conditioning, cooling centers, and public familiarity with heat safety leaves a population with far fewer tools to respond once a warning is actually issued. The honest, grounded summary is this. The heat wave dominating this summer has fundamentally changed character over the past several days, shifting from the dry heat dome pattern that defined June and early July into a far more humid, moisture-loaded event. New York City came within 1 degree of its all-time dew point record on the 7th of August. Lake Charles, Louisiana, sat under a tropical storm warning and an extreme heat warning at the same time for the first time since 2005, with a heat index reaching 121 degrees. And heat advisories have now reached interior Alaska, a region whose own formal heat warning system is barely a year old. Climate scientists tracking this pattern describe it as one connected global signal rather than a series of unrelated local events, showing up simultaneously across multiple continents this summer. We are going to keep tracking this as the pattern continues to evolve through the rest of August, sourced the same way we did today, straight from the National Weather Service, the Copernicus Climate Service, and the meteorologists actually explaining what is changing in the data, not recycled headlines. Subscribe so you do not miss the next shift, because based on everything we just walked through, this pattern is still actively moving. And leave that comment below. Tell me whether the air where you live has felt different this past week, and whether your own region has ever combined this kind of heat with this kind of humidity before. Because behind every one of these numbers is a family in Lake Charles, boarding up windows for a tropical storm while simultaneously being told to stay indoors for the heat, a resident of interior Alaska trying to cool down a home that was never built to need it, a New Yorker lying awake at 2 a.m. in air that never actually cooled down after the sun went down, and a meteorologist somewhere right now watching a dew point map light up in a place it has never lit up quite like this before. 5,000 likes on this one. Let us go. See you in the next one.